Okay, welcome everyone. Start the meeting with company update.
Yeah, everything's kind of getting moved into the Hong Kong office. We got a couple of mishmash desks and chairs. We got a tiny box. We're getting internet today. We're getting plugs on Thursday.
What on Thursday?
Plugs, electricity.
Oh, great.
Right now we have one plug, and it's kind of mediocre.
Great.
Yeah, I mean, that's kind of the main thing.
Any bucks getting more expensive?
Oh yeah, Nvidia raised the prices of the Blackwells. We literally it went to 65K, but that doesn't even we lose margin now. That doesn't even maintain our margin.
I see.
60 was a little aggressive last time, but yeah, no, now Nvidia raised the price of the Blackwells 1,500 each. So I mean, it was surprising how cheap they were, considering they have so much RAM on them.
Yeah. Okay, that's what it is.
But the red box is the same price. Those haven't gone up.
Great. Oh, that tiny box is a red box, I
The
assume?
red box. It's a red box, yeah.
Great.
Yeah, by the time we leave Hong Kong, I want us to be able to use open code against it, and I want it to run some model reasonably.
Okay, sounds good. Next item is a new thing, but let's go through open issues for Gamma. I see Wolfsberry, you say something.
Alma is complaining because USB GPU overhead is very high. So C-type structure actually increased overhead too. It's like notice.
Yeah, I haven't had a chance to look into that yet, but I will.
If you look at the issue, there's a patch in the issue. I don't know if it looks kind of weird, but a patch that drops it.
It's definitely not a good patch.
Yeah.
Yeah.
But yeah, I mean, we need to fix that, or if it's just slower, we need to revert it.
Yeah.
Basically,
so let's start by like logging this somewhere.
Yeah, we have to figure out how to get a test for this.
Yeah.
Yeah, I mean, if it's something that it's similar to our current assert, just find a place, log it, and then assert on that.
Yeah. I don't currently have a USB GPU on my desk, but I can get one.
I mean, yeah, you're in the home of USB GPUs, so
That's
grab
true.
Grab the one off my desk.
No, Henry took it, but I will get another one.
Okay. Anything else that Kama is currently complaining?
That's the only complaint. They said that if that is fixed, they're able to use USB GPU. So their current timing is 10 milliseconds copy in, 10 milliseconds copy out, 5 milliseconds model run, and 25 milliseconds of overhead.
yeah, I mean, we got to lower that. It's not even copy out. Like the custom firmware is not even going to fix that.
Yeah, I mean, ideally, we just want to get the number you cited, right? Like somewhere in the CI. If we can make that clear for the numbers, then we can even assert on the whole thing. It's more difficult for OpenPilot because the way they run the model, but maybe for USB GPU it's more clear.
We have, I mean, how much of this is the Comma device itself having a crappy processor?
A decent chunk is the column being slow because when Armand runs it on his workstation, it is significantly less.
Yeah. Yeah, I wonder how much we can do in the Qualcomm driver too. to avoid this kind of stuff. I mean, yeah. Oh, yeah, no, you're right. It's not the Qualcomm driver. Or I mean, the other driver, the AMD driver. Then, I mean, what if we move the AMD driver? Like, how much of it is when it patches the JIT, it's using Python when it should be using C? How well does set item assign work?
What?
How well does set item assign work? Can we start using set item assign to build the command buffers?
We start to use set item assigned to build command buffers. How does that work?
Well, so right now we build the command buffers. Like if you look at the HCQ JIT patching logic, it's slow because it's written in Python. But we could we can put that HCQ buffer in a tensor and then use set item assign on CPU to update all the buffer references.
Yeah, but I think it will still be slow for USB because of the abstraction.
Which abstraction?
I mean, to write into VRAM. You need all
Oh,
this USB stuff, yeah.
and we update it on the GPU?
Mm. Not sh-
How much of the
and no,
drive?
our queue should be on the controller itself.
I see. Um, is that slow for the? I guess the GPU accesses it fine. But yeah, no, I mean, this sounds like something you can work on. Like, let's think about how to make this faster.
Yeah, I'll take a look.
Yeah,
I know if something regressed, but
even
it
if,
was like the fastest way I could get it back then.
yeah, I mean, even if nothing regressed, like what I want to start to think about with all of these things is building the GPU command queue on the GPU.
Yeah.
It doesn't matter.
Okay.
It doesn't matter which memory it's in, right? If it's in the memory of the controller, it doesn't matter. The GPU can still access that.
Yeah, yeah.
We'll talk about that more in your item. I think for comma, let's find a way to measure it, and if we either fix that or revert that, I don't know. We pick something so that to unblock comma.
So while I'm here, should I put like one of those devices in CI?
So it's a little annoying. The comma devices currently are on Wi-Fi or Ethernet? Yeah, I mean, we'd have to use a hub.
What's on the comment right now?
One of the comments says USB GPU? Which one?
Some of them. I
Mm,
think one of them does. Yeah, I think they're both.
I see. I mean, we should probably get enough 9060s and we should put them in the comma CI devices. Yeah, if you want to do that, if there's enough of them.
You can put them on the 2,4s.
Okay. Okay,
Here,
I'll
comma-
see if there's extra that I can do with that with.
The people.
No, they're bad. They're bad.
Oh, they're bad. Okay, okay, okay.
No, no, no.
Fine.
Like a-
Fine.
What?
Wait, sorry, I think you got.
Oh no, I was just saying about. I heard we have comma fours, and I'm like, there's people who need those comma fours more than us,
Yeah,
but they're bad, so it's fine.
yeah.
Okay. Cool. Sounds good. Next.
But yeah, if you want to get USB GPUs, put them on the comma fours, and we'll get that in CI.
Okay.
Okay. Next is my item. set item doesn't fuse yet. So it's annoying to write.
I mean, we gotta fix that thing that's in schedule.
Yeah, let too.
So I merged something this morning kind of related to this that I'm very happy with. You can like the schedule is now like just a linear of what kernels it runs.
Mhm.
I'll push something today that will make I think I can at least remove the create schedules and the realizes from what you're doing.
Sure. So you mean not running multiple ones, or
Well, it'll still be multiple, but I'll basically like I don't know. We'll get to this for my thing.
okay, sure. Yeah, I mean, that would help a lot. I was trying something when I start to hit because we have like disable GC on realize, so it create like some weird auto memory thing because something's not free properly. I don't know.
I
So
mean,
let's
yeah.
yeah. I did some cleanup to the multi. I think now multi really looks a lot more like just a view-ish.
Right.
And start to look into disk. So disk, so this is for World's Parrot. Can you check the setup is correct or something? I think I fixed it, but I also don't know if I really fixed it. So I added, I wiped some unit test that I think is good enough, loads or pass before the regression, and it's currently failing. I think most of the issue is just we only check disk in the new allocate code, allocation code, not also the tinyfs, something like that.
Yeah.
Because before like moving all this disk logic, I also want to make sure the tinyfs is not broken, so I can fix these two together. So one annoying thing that we can quickly discuss is bitcast. So for now, we still have bitcast, shape-changing bitcast. And this is annoying because it has weird shape and it really is not element-wise. So this causes a lot of issue in scheduler.
Where are there shape changing bitcasts? That just shouldn't be allowed.
It's only on disk. When you write into
Oh,
that, it's only disk, and disk is kind of special because it's kind of a fast path. Like you can just read the consecutive ones.
I mean, I think the idea with disk is not to allow shape changing bitcast, but instead to write a compiler. It's not a real compiler, but like have disk follow the same path as all the other things, and then just like compile certain things with a bunch of graph rewrite rules.
So that was my approach, and I almost finished it. So basically, the idea is you never need to bigcast your view on the disk. You always bigcast your source. So you just get a bunch of things that is uint8, and you always kind of just assign which lowers to a copy to a segment on the disk.
I see.
I think that's how we want to do it, and in that way we can like remove this path for the bigcast altogether. I think it's just some small syntax thing that we currently put in bigcast. I think that should work.
Right.
Yeah, so if Woodbury can help me figure out the tinyfs is good, then I can work on
Yeah,
this.
the benchmark thing should be fixed.
Okay, great. Yeah, because I also saw like bigcast causing other issues in element-wise and shape. So hopefully these will get cleaned up. I think the special thing for disk and tinyfs would still be slightly special, but it's not that crazy, so should be fine. Oh, and speaking of multi, I also have a change that so now I think we have some regression that we are realizing const when we do the sharding on const or something like that. I don't think that's intentional. I also I want to fix that. Then similarly, I think now we are ready to write the A range. So when if you shard an A range on like non-copy way, then that A range should be compute on each device. So I also have a change for that I'm testing.
I mean, yeah, hopefully you're seeing these abstractions become a lot better with like, you can do multi now. You don't have to worry about trying to track tags or anything.
Yeah, that's very good. I removed the force reshape. I am looking into the no op. We still use no op in a weird way, but it's less and less.
Yeah, no, I mean, there's that no up used for copy, but that'd be nice to remove.
Yeah. So I think these are all kind of related to each other. So I'm just like finding ways to eventually get to the bottom of these.
Great.
Okay, that's my part. Next, we have drivers.
Yeah, so for the tiny AMD4, I think we print more more errors now. So we print something special to MI 300 machines, which is called like architecture check. So actually it shows the error on tiny AMD4. So as for a Pro, I tried to run some all reduce, but it was fine. And actually, even the last, I haven't run the full run yet, so maybe it still has some issues. But even after CPU offloading, I mean, passes most steps. Yeah. So for the
What's CT offloading? When you try to run on AMD4 now, does it give you an error or does it still HCQ timeout?
yeah, it should print the error.
Right. Because I was saying yesterday that there's some way she's still hitting HCQ timeouts too.
Yeah, I've seen that. Actually, that's, I'll take a look into that. But basically, that's the Mac just dying, and actually, you can dequeue the queue.
I see. Is
So
there
yeah,
any way we can detect this? Because we should really be treating, like I used to talk about just lowering the 30 seconds down, but I don't think the answer is lowering the 30 seconds. I think it's just that we should treat anytime we hit that 30 seconds as a pretty serious failure.
yeah, I see. Yeah, I'll take a look what I can do. I think AMD GPU is kind of the same. I know. I'll try to understand which instruction causes that, and yeah.
Yeah, I mean, we should
But
really just
actually,
like pause it. Anytime
yeah,
we can hit that HCQ timeout, something went wrong.
yeah. But actually, all channels we have right now, we have no errors reported to them, and actually, it couldn't recover after that because like Mac stopped responding at all. So yeah.
And then can we still end up in discovery signature mismatch failures? Rose Parrot saying yes.
I think yeah, but
What can we do about this?
I think once we are in this state, I doubt they can do anything about this.
How do they get in that state? Do we have a repeatable way to put them in that state?
So I think on TinyMD4, yeah, you can just do high resets. That's what
I
I'm
see.
aware of. Yeah.
I can put them pretty consistently into that state on 3 as well. If I have a training run going and then I let it run for like 300 steps and then I control C it and then I high reset, it'll go in that state like immediately.
Why does the state happen? Do we understand it?
No, not really.
I think this is a good project. I think we got to figure out I think we got to understand it. We got to figure out like, because there's something we're doing, even if we can't recover from the state. there's something we're doing that puts it in that state. We got to understand it. We got to make that reproducible.
Yeah. Okay. Yeah.
Yeah. I
Uh,
mean, yeah, we got to just improve stability overall with this stuff. Every error should be thrown. Every bad state should be completely understood. And ideally, we can, if we can get into a bad state that requires a reboot, we can complain to AMD about it.
yeah.
Can this happen with the RDNA 3 and 4 cards too, or it's just CDNA? Discovery signature thing.
Yeah, it's just CDNA.
Just CDNA, yeah.
It's
Yeah.
I think it's even like MI350 machines.
300s?
Not 300s,
No, I
350.
know. Have you ever seen it on 300s? Okay. Yeah.
No,
So,
no.
yeah.
I mean, I just
Yeah, I mean, anything we can build to put it in that state, even if it requires our driver, we can complain to AMD about. I mean, they need to add a real reset to this card.
They have no way to actually order them.
Take over.
We'll just make it.
Yeah. It's small. Can I try to go to cat.com?
Do you say something? You're really muffled, if so.
No, we can move on if there's nothing else. Again.
You good? Okay. Let's move on. Next is Chris.
Yeah. So I wrote up an issue, or a tip about what the new renderer API can look like. Yeah, I mean, it's kind of what I talked about last meeting, but I think I sort of fleshed out a lot of the ideas a little bit in more detail.
Did you see my reply?
Yeah, I did. I also replied to that.
Okay.
Yeah, I mean, obviously the names, like, I'm not particularly tied to any of them. The
Well,
thing about each, yeah.
it's not just the name. I don't understand why it's called cross arch and not just arch, right? There's nothing cross in it, right?
Yeah, yeah.
Or am I
no,
not
that's good.
understanding something? Yeah.
No. You're right.
Yeah. Okay, so CC is the renderer, right? So I
Yeah.
guess, like, why can it not just be rendy? Right? Why does it have to have an underscore?
Because so it seems like a valid use case to be able to specify both the CPU renderer and the like AMD renderer at the same time, right? So you may say,
Yeah,
oh, I
okay.
want to use, yeah.
So then every device just basically has one renderer. I mean, we also need to canonicalize these things as strings so that it can all be, like, put in rewrite rules.
Like, what if you want to use multiple renderers per device?
Yeah, so that right now that's not really a supported use case. In fact, you would have to, well, you could do it as a context var. So this currently works. So you can say, like, okay, like right now I want to use this, and then later on I want to say, okay, well, actually, rewrite, CPU underscore CC to be something else. And then if you call realize again, then like and get program runs again, then I believe this works. Because it accesses the renderer, and that's a property, and the property recalculates.
Why can't we have something like a target triple that's like AMD-GFX 1100
Well, no, because it's not on a different device, right? Like, the device is what memory it's on. And it's not like you'd want, like, some devices. We used to have this, but it was really bad when we had things on the CPU device and the LLVM device, right? They're not different devices.
Yeah.
Like you can split the target triple into how you parse it. Right? Like the first thing, you just take the first thing out of the target triple, and then that's the device it's on.
No, but how does this work for like we haven't talked about like so I want to compile some stuff with Clang and some stuff with LLVM. How do I do it?
Yeah. So I mean, right now the way that you would do this is you would say, you know, like with CPU CC equals LLVM, and then you do your whatever you want to do, and then you would do with CPU CC equals, you know, Clang, and then you do whatever you want.
Well, I definitely like rend better than CC. I think this
Yeah.
is fine for now, and just have it be a context var.
Yeah.
And yeah, so
Yeah.
it's just
And then
CPU underscore rend.
yeah,
But now
there is yeah.
should it be CPU underscore arch?
Oh, that's a good point.
Right?
Well, okay. Are you ever gonna?
You have to, right?
Yeah, I guess it does.
I mean, it's already still. Then you have the same question too: is what if I have a computer that has an RDNA 4 GPU and an RDNA 3 GPU?
Wait. It does not. Wait. Sorry. Oh yeah. Okay. That's true. But then also, it doesn't need to. Arch does not need to be. That's not necessarily true. That Arch needs to be per device, because you will only ever specify Arch. I mean, in theory, you only ever specify Arch for null and Python. Right. So it doesn't necessarily need to be per device.
How do I specify arch for null is what? It's going to be something like AMD colon or something?
So for null, what you would do is you'd say like null rend equals, you know, qcom colon cl, and then arch equals a630.
I see. So why is it not? Why is arch just not included in the renderer then?
That's an option.
Kind of like
Yeah,
that,
that would work. Yeah.
right? If you just put arch in the renderer, and then the renderer kind of has a triple, right? So the renderer triple is device.
It's only a triple on null though, right? Because
You use null for compiling, right? For export. But if I want to export to Virginia, I want to export to. So Comma had this use case before they moved everything into one JIT, where the policy model was run on the Qualcomm GPU, and then the vision model was on the USB GPU.
Yeah, I think we got to stop thinking about things in terms of like these discrete renderer, arch, and device things. Like, I think we want a triple. That's those three things, right? I think it's device colon renderer colon arch or something.
so maybe you do want like target equals whatever.
Yeah.
But does target encompass device now? Like,
Well,
anyway.
okay. So a key thing about the arch and the renderer is that they don't affect the memory.
Yeah.
Right? But then we also have this thing where so this requires more thought still. Like we also have this thing where there's multiple devices, right? So how do we deal with that?
Yeah.
How do we-
Well, so I mean, this right now is parameterized over the device object, not the renderer object. It feels to me like this needs to be, yeah.
Shouldn't have anything to do with the renderer object. The renderer object should not require the opening of the device.
Yeah, exactly.
Yeah, so I don't know. I think this still requires more thought. I don't exactly have all the answers, but I think that what maybe the next thing to do is in that tip, think about different user stories and make sure you cover all of them.
Yeah, for sure.
Because yeah, I mean, we need to be able to change renderer. We need to be able to, like, yeah, the export to the heterogeneous system, right? Like if you're compiling on a CPU and you're doing stuff that has some stuff on the Qualcomm and some stuff on the USB GPU. That's what you meant, right?
Yeah, exactly.
Yeah.
What I would say is that we're partial towards a system with fewer environment variables.
Yes, and the other thing that I think is a good intermediate for this is to work on the graph rewrite such that renderer is not passed as a context variable.
Context variable?
Right now, renderer is context in a lot of graph rewrites.
Yeah. Sorry, I got confused by context. Yeah.
Yeah, and it shouldn't be, right? Like we want, I don't exactly know what the solution is there either, but my point is that once we produce a graph, like the renderer should be taken from, right? Because it can't be a context variable because that graph rewrite can support multiple different lowerings potentially. Or maybe it is
Yeah.
context and it's just sat. I don't know. But yeah, these things have to be thought through. Like I'm thinking about like the program UOP, and the program UOP, like when we go from linear to source, the program UOP needs to have not just the device on it, but also the renderer.
Yeah.
Cool. And I think there's just more to do, more to discuss on that tip. How's image coming?
Yeah. So, I mean, I know exactly what the performance difference is right now. It's there's one kernel, which is eating up like we're about like 2.5 milliseconds, a little less than 2.5 milliseconds, behind like image equals 1 is that much slower.
Okay.
And there's one specific kernel.
So I
Which,
see 3 milliseconds on your cast thing.
yeah, that one was actually slower. I'm not going to merge that, but that I thought for whatever reason it seemed like it was testing faster, but it wasn't.
Well, I mean, it's not. So there's 154 kernels.
Yeah. So that's there's those are the two problems. Is that one of them is that there's more kernels. There's approximately 30 more kernels.
Okay.
And then there's also one kernel which appears in both cases, but it is slower in the image equals 1 case. And this is down to it looks like a bug in the Qualcomm or a failure to optimize in the Qualcomm compiler, in the Qualcomm CL compiler, but I'm going to try and figure out how to get it to output the same code.
How much slower is it?
So it gets called 10 times, and so it's a tenth of a millisecond slower each time it gets called.
I see. So yeah, probably something we have to address. But yeah, the Qualcomm, we shouldn't waste a ton of time on things that are equivalent. The kernel thing is much higher priority than fixing the Qualcomm compiler thing.
Yeah. So the kernels thing is down to the fact that I'm using .cast, .contiguous, .cast. And that's causing the scheduler to output additional kernels.
Contiguous is real, right? You can't reorder contiguous or anything like that.
Yeah.
So why do you need that?
To denote that you're storing as like the data is stored as half, but loaded as float.
Yeah, so I would remove the contiguous and figure out how to add a rule to do the graph split in the place where between the two casts.
Okay.
Right, like you don't want to use contiguous for that necessarily.
Yeah, no, for sure. I mean, yeah, I mean,
Right,
splitting the graph. So
the thing should be smart enough, right? When it's deciding, so this seems like it's going to have to fix look at Derangify and
yeah.
say like, yeah, if you have like a a long chain of binary ops, and at one part in the chain, it's
if you have a long chain of binary ops and at one point in the chain you cast and then cast back.
Yes. If you have a long chain of binary ops, you cast and you cast back, then the split point should be before the cast back.
Yeah.
If you cast to a smaller detail.
You also
need
to look into why is there like materialization in that chain, because if you only have cast, then it's not a new kernel.
That's true. Yeah. That's true. I haven't tried
Or it
removing.
must be like there's a fork, then someone also use it, then maybe the rules. There's a rules to decide the kernel boundary, and you just need to.
No,
adjust.
no. It's simpler than that. So it's basically just like, okay, say you have something like ReLU, cast half, cast float, expand, gem, right? I believe currently that cast float will not go with the gem. That cast float will go with the ReLU.
Yeah, probably. You put the cost function, but you know better.
It's not a cost function thing. It's even stupider than that, right? Like, because usually the difference is it's kind of like normally you don't want to do ops. Like, let's say you had a ×2, right? You would want to do the ×2 before you store because you don't want to do that ×2 1,000 times. Right? You don't want to do that ×2 for everything in the reduce loop. But for casts, you do want to do them. So I don't think you need a cost function. I think you just kind of need, it just should be like binding precedence.
Yeah.
Isn't it depends on how many times you expand?
How many times you expand, it doesn't matter. Basically, you want to make casts from smaller things to bigger things, like right associative instead of left associative.
Yeah, makes sense.
Well, okay. So the other thing that's worth pointing out is last time we talked about this was with regard to the BERT trainer, right? And this does it in the opposite direction, where we store in float and then do the math in half, right?
Yeah, but
So it's not. Is that right?
I think that's a slightly different use case.
But it is worth pointing out that it's the opposite way around, right? Like the split rule there is different.
You never want to do that. You never want to store in big memory. If BERT's doing that, then it's doing something stupid.
Maybe I misunderstood the code then. I'm not sure.
What?
You store master weights. Every 16.
But you store the master weights in FP32 because the
Yeah, so my point is there's nothing before your loading weight in flow32, right? You don't have a chain and decide like where to materialize. You always have your weight in flow32, then you do your cast and then do your ALU after that. So it's different here that you have a full chain of stuff and you decide like where to materialize your kernel.
Yeah.
Yeah, I mean, if it's already
Yeah,
material, right? Like, I'm not saying that you change the behavior of cast from float to half. I'm just saying you change the behavior of cast from half to float to be right associative.
Yeah. I mean, the other thing that's a little bit weird here is that like if you put a dot cast half dot cast float everywhere, like if that doesn't, if for whatever reason that doesn't get materialized, like if there's no break between there, then you've like lost precision for no reason.
It should optimize it.
Yeah,
should optimize it out on the kernel compiler.
That's a different. Sometimes you might really want to do that.
Yeah, this is the thing I've noticed. Is like
that's not.
Okay.
But yeah, no. The top priority here is to get the kernels down to match the old kernels.
For sure.
If you get down to something where it's the Qualcomm compiler, then we can talk about it. Clearly, we're not there yet.
Yeah.
We're 3 milliseconds off, and the kernels don't match.
Yeah. So that I'll on the number of kernels thing.
Right.
And I think this one you can just, if you believe the issue is with the image memo, then just write a very simple image memo. You should see that. Go from there.
Sorry.
I found the web GPU NAND things. There's still some issue. It's not very important, but it's kind of annoying.
Yeah, I saw this. So the thing I
think that's probably because we decomped the equal. Equal should, so if we have a special definition for equal, and we'll probably also need that for the equal because we support both.
Yeah.
Get something like that.
The thing that I fixed was isnan, nothing, and like there's also like comparing is also broken with WebGPU. So you just have to check manually if you're going to do a comparison of floats. You have to manually check if they're nans.
Yeah. I mentioned this because this seems to be a natural follow-up, just similar to the other one, the 3-fry hack thing can be removed.
Oh yeah. Yeah. I mean, this doesn't really have anything to do with decompositions, but I can definitely I mean, it's an easy change.
Yeah, the web GPU NAND thing, I don't know. I don't care that much about this. Like, this is just because web GPUs operators don't behave according to any spec. I don't know.
Yeah, I mean, for what it's worth, it works on metal.
Yeah, my point is we currently have special code to try to handle this, right? So we either don't care at all or try to care
yeah.
more. I don't know.
That's true. That's
I think that we shouldn't. I think that the web GPU NAND can just be ignored and just be like that backend doesn't support that. I don't know. I don't like. Yeah, whatever it is now, I'm fine with.
I think if it's simple as we just redefine isNAND and not isNAND to the equal, and if that fix everything, then it's good. We definitely don't want to go crazy and like write more stuff.
Yeah. Yeah, I mean, it's not that complicated. It's you just if you have compare, you just you check if either one is nan.
Yeah. So, okay, cool. Okay, next is Llama.
So I have a completed run with optimizer offloading, and then there's a current one going with that's model parallel without optimizer offloading.
How slow is it?
So this one, the model parallel one is 8 seconds a step. Is 16. And then the optimizer offloading one is like 5 seconds. Also, yes.
I mean, I graphed the optimizer yesterday. That grad clip thing is we got to switch to fuse optim. I mean, like proper fuse optim. I also think that, like, I remember last meeting we were talking about switching what tensor.cat uses. But I don't even think we have to switch tensor.cat. We just have to switch the optimizer.
This meeting you said we should switch tensor.cat.
I know. But switching the optimizer is fine. What do you mean? Was that the other option last meeting?
Yeah.
Oh, I didn't understand. My point is, we could switch either one. It doesn't matter.
I'll test switching the optimizer.
Oh, sorry. If that was the other option, then
Yeah.
and we have to basically get fuse optim to work because then there should be little penalty for optimizer offloading.
Yeah.
Is it currently not working?
Is what?
It should just work, I think.
It works. What do you mean?
Fuse optim?
Yeah.
Oh no, a fuse optim doesn't work because of the cat.
No, the cat is very big.
Oh, I see.
AMD compiler complained that there's too many brackets, and then if you up the bracket, it's egg faults.
Wait. Too many brackets can be fixed in the renderer. I actually have a fix for that in the Python renderer.
Yes, and then there's also too many inputs into it.
Well, that's a different problem.
Yeah.
Yeah, I mean, I don't know. We shouldn't like be doing that.
How many inputs? But you cannot just split it.
No, I mean, what you need to do is, so currently we set each gradient to 0. We shouldn't be setting the gradients to 0. We should be setting the gradients to a slice of some big thing that's 0, and then everything becomes an assign. See what I mean?
Yes.
Yeah, so I mean, that's what it has to become, right? Like the gradients should not each have their own buffer. The gradient should be assigned to a large gradient buffer. Like set item assigned.
And wouldn't it be nice? Wouldn't it be nice if all these fuse into a single kernel or something?
But even if it doesn't fuse, I mean, we could at least start by fixing the like, right? Like so right now we have like something like 0 grad or null grad or something, right? Instead of doing 0 grad or none grad, we want to assign each grad to a slice of a tensor zeros. Like set it, and then when it does plus equals, it'll do the proper assign thing, right? This
What's
makes
the
sense.
benefit? What's the benefit of this?
Because the outputs of the gradients are stored in one big contiguous tensor.
This is only good if you want to do gradient accumulation, right?
No,
Just
it doesn't matter. No, it's for fuse optic.
Yeah, that's what I mean.
Yeah, not for gradient accumulation, for fuse optic. So basically, like all of your
Basically,
gradients.
you want your gradient when it's all ready, you can just work on that giant thing, multiply it by learning rate or something, and work on the full thing instead of split it.
Yes. In fact, you can even go crazier and assign all your weights like this too.
Okay, that makes sense. I think
Right.
I remember I tried this while I was trying the gradient accumulation thing.
Yeah, no, you shouldn't need it for. It shouldn't make any difference for gradient accumulation. But it should be one really big gradient tensor that then goes into the optimizer. And instead of each gradient being assigned to a new buffer, all the gradients are just assigned to a slice of a large tensor.
Great. Was Barrett okay?
You think we'll get a? How are we on RAM for 405?
Uses quite a bit.
Well, our 8B is the same as AMD's. It's not worse.
This worse.
No, they have double the batch size, but they have half the precision.
I also don't know if they're optimizers target.
So,
At least the run I'm doing right now is optimizer as well.
that other stuff works. It's not fast.
We still miss one ASM gem, which is the output one.
I don't know why. Oh, because the
No,
outer
it's
started?
the weird shape. Like, is it 128 you shard it across 8, and then the shape is no longer multiple of the tile size.
Yeah, I don't know. How slow is it? Bad.
I'm not more about this. Auto parallel actually hits more ASM gem than the parallel does.
I thought data parallel was 100% ASM. What?
There are some things.
Oh.
I managed to get all of them.
We'll put the 405E memory somewhere.
Do some math to figure out what it is.
I just do the null backend.
Yeah.
Yeah, just run the no backend to see it like is it 10x off, 5x off, 20x off, something like that.
Hopefully it just fits, and then we don't have to worry about anything.
There's no way it would just fit.
It won't fit, but I suspect we're going to be 3x off.
If it's 3x off, we can think harder about float 8.
The memory counter. What exactly does that measure? Because it doesn't seem to line up with the GPU memory allocation.
So, this is the other thing. I want to add the peak memory usage.
I don't exactly know what the men used global counter means.
Means
Then
buffer.
use is
Like on all devices?
yes.
Oh, yeah.
It's like the sum of allocated thing, not including the one that's still in LRU cache.
And not disks. There's a
And not
special exclusion for disk. I mean, this stuff's all really easy to compute now on the graph. And we'll move the memory planner to the graph too.
Any thoughts on peak mem usage?
Like, I mean, the kind of whole place that I want to move this stuff to is just having one schedule. Or like one. And then if you want peak memory usage, you can just like add them all up. I don't know. If you want to add to
Right.
global counters of peak memory usage, by all means do it. If you want to do it per device, by all means do that too.
Yeah, I think these things are sometimes you really want it because otherwise it's very hard to write some test. Then to think about it, then you forget about it.
Yeah. We could add global counters.
Okay, does that answer your question? Was Parrot?
No, because it's still kind of a useless number because it doesn't tell you how much is on the GPUs or how much is on the CPU. If you're
Yes, that's the per device mem used.
Per device.
we need per device.
On the null device.
That's
Okay, leave it to you to decide how to better write this or figure out the memory. And we can move on to co-emperons.
Yeah,
And
so
linear schedule.
yeah, so hopefully my refactor this week was good and useful. We're almost finally achieving the dream of it being a single graph rewrite that lowers everything in a pretty sane way. And the JIT will also kind of be free as well. Like all of TinyJIT's going to be deleted. It's clear what it is now. We're really close to this. So linear schedule is just instead of like there's already an op called linear, and this op linear is used in linearization of programs, which just has sources be like the order of all the uops in the program. So linearization of schedules is the same thing. It's just all the calls for the different kernels. There's one op called linear, and all the sources are just the calls for the different kernels. And now things that used to be bespoke code, like so all of those kernels are themselves in the schedule cache with params. But now in order to convert those params back to buffers, it's not bespoke code anymore. It's just a graph rewrite that replaces all the params with buffers. I also added a rule to graph rewrite, built into graph rewrite, to not traverse into the source 0 of call. And because you don't want to do this most of the time, like you don't want to traverse into the function. If you do want to do this, what you do is you create a rule, a UPAT that matches the call, and then you can call graph rewrite in that rule, and that will create like a graph rewrite with a different context. And the reason for this is scope. So like call gives tinygrad scope, and this has been something we've been desperately missing. This is why like llama is so slow, because nothing is scoped. We put every single op of llama in a huge graph. And we have no way to specify that there's repeated structure per layer. But the new
that's the deleted.
That's the what?
That's the removed outer word range.
I removed all the outer world garbage. There's no such thing as an outer world and inner world. There's just nested calls. Right? Like that's as stupid as trying to write a C compiler where you have main and then main can call functions and then functions can't call functions. Nope. Everything can call functions now. You can call functions to arbitrary depth. And this will also allow the nesting of JITs.
Oh, great.
So like, think about just JITting a single llama layer. We'll be able to JIT this, and then that llama layer will not be compiled 24 times. It'll be compiled once. And the parameters will be set correctly, the same as the JIT. Yeah, the other thing about linearization of the schedules is hopefully now Navelgen, maybe you can see how we can just do a rewrite rule to rewrite that linear to command buffers.
Yeah.
I mean, I think that's the ultimate dream.
like the GPU command buffers themselves, it's just a language. Sees the buffers, gets the address of the buffers, sticks them all in the thing. It's all nicely parameterized. The JIT thing is just a graph rewrite where it replaces the. I mean, we've already done some of this with the synth stuff, but yeah, I think we could take it further and actually just build all of the command buffers in basically a renderer for a AMD mech device, because that's what it is.
Yeah. Yeah, looks good.
The other long-term thing, I think we should start to like, while you're here, in Hong Kong, we have Tiny Box. I want to be able to, I mean, hopefully, is there already a way for me to drive the GPU over the network?
Right now, no.
Yeah. Yeah, we gotta start thinking about how to add that, right? Because I want like a server running on that Tiny Box, and then I want to be able to target the device. But it should be the same, isn't it? The same. I haven't really read the Apple stuff, but isn't it the same abstraction as that?
Yeah, it should be absolutely the same abstraction on the Tinygrade side, but yeah, we need server.
This week, if you use the same abstraction, just encapsulating PCIe.
Well, yeah, but where do you want to? We'd have to just run a different process then. Rather not do that. Right? Like, yeah, sure, the server should be able to use USB GPU, right? If this abstraction hierarchy is done correctly, you should be able to run a server on a machine with a USB GPU, and then other things can happen. No, USB 3 is weird. I wouldn't try to. I think that's fine to stay in process. I think there's actually advantages to it staying in process too, because you avoid an extra layer of indirection. Yeah, no, I want to be able to use GPUs on a remote computer. I want my normal workflow here to be all targeting the RDNA4 GPU on the Tiny Box, instead of the GPU in my laptop, because the GPU in my laptop crashes. It's terrible. If I could just like, sometimes, yeah. Or like if you write a kernel that hangs for over a second, my whole thing goes down. And this isn't anything we're doing wrong. This is just AMD GPU being crappy. You can do the same thing in here. But if the GPU is physically on a different computer, I mean, what I'm expecting this to have like no overhead. I'm expecting this to be like USB 4 tier speeds. And I mean, okay, whatever I get over gigabit Ethernet or whatever. So, a little bit slower, but yeah, I mean, I'm expecting this to be like the normal way to use GPUs. Yeah, and then we think about how to start making these things. I mean, this is the other reason that we need to like, you need to just get all of these abstractions perfect, such that when we like lower things to AMD mech, it becomes easy to broadcast that to 1,000 computers. Like all 1,000 computers are running the server. I could never put 1,000 GPUs in one laptop, but I can connect to 1,000 TCP sockets and loop through them. That shouldn't even be slow. Should it? What? What's so slow about that? Yeah. Do you think the server is going to be like? I think is the server per GPU, or is the server one for the whole memory space?
I think it should be one for the whole memory space.
I like that. Yeah, it's just like the remote memory, maybe remote direct memory.
What? Okay.
An RDMA, yeah.
Yes. Okay.
Over RDMA again.
How non-custom can we make it? How much can we use this RDMA? Is there a real protocol we can use here? It's not important. TCP doesn't support address spaces. It can be encapsulated inside of TCP. Yeah, I definitely don't want UDP. I don't want my memory accesses to miss or be out of order.
It's DevMem. The TCP goes right to the device.
That's DevMem TCP? That's when?
It's 17.
DevMem TCP?
You two can work on this.
Oh, cool. Oh, I like this. Oh, yes, we should. Great.
Postparrot, can you review my change? I think left fix
I'll review.
TinyFS. Great. Then I look forward to George your refactor to whatever assigned thingy is.
Yeah, qualify. Yeah, great.
Great. Okay. I think that's it for this meeting. Thank you, everyone.
Thank
Bye-bye.
you. Bye.